Page 166, remember the t-test has two groups. You're looking at least interval data. You're comparing the means for these two groups. So let's click on Analyze. And then it says click Compare Means. And we want independent samples t-test. And here we already did this earlier today. We did the item variable. Let's do some different ones. Variable. So take your variables now. Again, that's where these little bars and symbols are coming into play. And you remember how we get those. When you have your variable view down here, you're putting in the kind of data you've got over here. And that's where it gets you these symbols. Okay, so I want to get symbols that look like this, because that's my metric data. So let's get some metric data and throw it in there. Let's take Final 5 and throw it in there. Let's take Teacher 8 and throw it in there. Let's take Diff Easy, throw it in there. It's changing, we'll throw it in there. We'll throw one more in there. Let's see what else can we throw in. GPA. Okay, we want to compare a variable that's got two categories over here. Sex would be a good candidate. Notice the question marks. You got to define the groups. We already did it. 1 and 2 are the groups. Hit OK. How many t-tests are we going to get? 5. There they are. Here's our means for our two groups. Here's the number of each group. Can you tell by looking at this whether the means are significantly different?
Yeah.
The answer is no. Unless you're some kind of a genius. All right, so I want to get this over. Okay, so first of all, you come down here and you look at this value. This is testing whether the variances for my two groups, males and females, on this variable are the variances equal. What does this tell me? I accept or reject that the variances are equal.
Reject.
I reject. So there, do I want to be in the top row or the bottom row? The bottom row. Go along this bottom row. See, I'm scooting along here until I get to this point. And this is testing now whether the means are equal. And what do? Accept or reject that the means are equal? Okay, so the means are not equal. I come back here. Now I can say males want more weight on the final exam than females do. My conclusion. Pretty straightforward. So, Nadia, help me on this one. For Teacher 8, what do I do with this?
Reject.
Reject, so I want to be in the top row or bottom row?
In the bottom row.
Okay, so I'm coming over here, and I want this guy, and what does that mean? Nadia's gotten quiet. What's this mean, Nadia? Talk to me, Nadia.
I'm thinking about it.
Okay, it's less than 0.10, so what does that mean?
So we reject.
Well, we're going to reject, and what we're rejecting are that the means are equal. Right? That's what we're rejecting, means are equal. So you can come back up here now and interpret this. Who is more likely to give the teacher a higher evaluation? Males. Okay, pretty straightforward. So Maribel, help me with Diff Easy here. Diff Easy, what do I do? What's this tell me to do? Yeah, I think our cutoff here is if it can be less than or equal to 0.10. You rarely get it hitting 0.10 right on the nail. But if it hits 0.10 right in the nail, you can assume it's less than or equal to 0.10. So in this case, we'll reject that the variances are equal. So that means we want to be in the top row or bottom row? Maribel.
Top row or bottom?
Oh, you can't see. Well, that's a problem. All right, Jeff, help her out.
Bottom row, right?
Okay, we'll be in the bottom row. And then we want to, here's 0.054 for testing whether the means are equal. So what's this do for us, Jeff?
Reject.
We're going to reject that the means are equal. So we come up here, and what does this tell us?
That males are more likely to do something.
Well, it's not more likely so much. These are their mean scores on Diff Easy. And you can see that males got a higher mean score than the females did on Div Easy. So what it's telling you is males think the class is easier than the females. That's what it is. You have a higher. So Daniel, monotonous changing. Let's look at that one. So Daniel over here, I don't know if the Daniel behind me is ready, but we'll Daniel here. So Daniel, what do you do with this 0.74, 24?
Accept it too.
Well, this is going to tell you what does it tell you to do? Stay in the top row or go to the bottom row?
Top.
So you gotta stay in top.
All right, we stay in the top. We're going to accept that the variances are equal. So we're assuming equal variances. We stay in the top row. We scoot over here now to the 0.194. And what do we think about the means?
They're equal.
30.
I'll throw your voice, Daniel. What are the means? What do you think about these means, Daniel? Do we assume they're equal or not equal? This is testing this hypothesis that the means are equal. What do we do? Accept or reject that hypothesis?
Accept.
Accept it. Accepting the means are equal. So that means, as far as we're concerned, these for the monotonous changing, these two means are equal. Now notice, by the way, it's kind of strange, but for some reason, these means were significantly different. Look at, they're only 0.367 difference from each other, and these seem to be. I guess it's not. I guess it's used a little further distance, and they're actually considered equal. And why is that? Well, it has to do with the variation of the data. And I guess people can play when you're looking at these differences. But we have to assume these are equal means. Okay, GPA 4. Nico, can you help me with GPA 4? So we're testing whether males and females have the same GPA. We look at this 0.002. What does that tell us?
Oh, sorry.
Yeah, I know for Nico and NICO. All right, rejecting it. So we're assuming that we're on the top row or bottom row? We're on the top row. Now we come over here. What do we assume about the means? 0.040 is our p-value. Means are equal. We were accepting or rejecting that? And we're rejecting. It's less than 0.10. Less than 0.10. So we're rejecting this. So now we come over here, and what's our interpretation on this variable, Nico? Let's go back here. What did we just do? We rejected the means are equal. Just kidding, huh? Well, one kid like that in the final, it'll knock your point.
Shouldn't you be in the bottom row?
Oh, you're right. We should be in the bottom row here. 0.041. Yeah, same.
It's the same.
So again, we still rejected the means are equal. And so what are we excluding, Nico?
They were rejecting that the means are equal, so you're not equal.
They're not equal, right? And what does this mean about what we're going to conclude here about males and females and their GPA?
So their GPA is the same. No, not the same.
It's not the same.
Unless they're smarter, they will, well, it's just a higher GPA.
Males have a higher GPA than females. Just look at it. Males have a higher GPA than females. What's the conclusion? Yeah, isn't that 2.86 for males and 2.68 for females? Something else. Males have a higher GPA than females. Am I reading that wrong?
No?
Oh, okay. I mean, it was fictitious data, dude. Don't get all excited about it. But that's what it's showing. Nico, what's the question? Does this seem okay?
Oh, yeah, the 6 and the 8 kind of look the same usually.
Oh, maybe you need to skip, but we need an even higher row, closer row. Oh, we need glasses or something.